Hi, this recording is for my course Theory of Programming Language um, for my laboratory exercises number 007 with the title of Activities Expressions. So, what is the objectives? The objectives of these laboratory exercises, is to differentiate the evaluations techniques of different programming language and expressions. Then what materials that I need is C++, Java, and C Sharp. So the procedures is we write the program below in C++, Java, and C Sharp, run them, and compare the result. So this is the given program is integer functions, integer k pointer k, then k pointer k plus equals to 4, return 3 times k minus 1, and main method with a sum1 and sum2. Okay, so the question is explain the result for each version of program C++, Java, and C Sharp. So let's go in my code. So I created a C. I already pre-created a C Sharp, Java, and C++ based on the given code to explain and demonstrate to you what is the result. So let me go to the C++ first. Okay, this is a C++ code that I created using the given program. So let me try and run this first, then I explain the details more. Okay, so based on the given program, that there's two output is equals sum1 and sum2. If you can see here, there's a sum1 here and sum2, sum1 and sum2. So here I just rewrite some code and add some display. So just to display the result. So the first sum is equals to 46. Then the second sum is equals to 48. So this one I just explained to you. What I did is this is functions that I created. It also give similar with the given formula is something like this one. So this is the integer functions, integer to k, which is put asterisk to become a pointer k, and this pointer k and plus equals to 4, and return 3 times k minus 1. So this is the method I call our method of function. So another method is my main method is this one, which is the trigger point. So this I put the integer. I put a local variable I equals to 10, and j equals to 10, sum 1 and sum 2. So I declare this I, j, sum 1 and sum 2 as integer. So where I put 10, I is declared with a static or with a value of 10, and j with a value of 10. So if you can see, notice I and j will be the same. And here, okay, we go to the first expression. So first expression is sum1 equals to open parenthesis I divide 2 close parenthesis plus functions of functions I, which is here I will call this I put some ampersand because this here I make the I make the parameters called in my functions. In my functions, I put the parameter k as a pointer. So you might need to put this ampersand to declare. So when you put something like a pointer, you are pointing the value and to the other side, to this function. And when this function is called out, this I will become the pointer where become the K. This one I here, and here K become this one. And when it return, it will be this K value. Okay, this K value will become the I value. Okay, so what it happened is, for this someone is, I already do some explain here. Someone will become someone equals to this I will pass the value of 10 and divide 2. So 10 divided 2 will become 5. Okay, and here the function is okay, the function is something this I become it all pass also 10. Okay, so I because based on these expressions, I will make the value, some value of this one first before I go to this second operands. Okay, so here 10 divided 2 equals to 5, and next is I go to these functions. So this function I pass the value of I equals to 10 here. When I pass the value I to k become 10, so 10 plus 4 will become 14. So this k pointer k will become 14. So it means this I actually will become 14. So 3 times 14 equals to 42 minus 1, it will return you the value of 41. So that's why you can see here 14 sorry here you can see here the value is 41. So 5 plus 41 will get the 46. So someone will get a 46, which is correct. Now we can, if you notice here in the sum 2, which is also same, the only difference is the expressions how it evaluate first. Okay, this comes okay in this sum 1 and sum 2, there is called side effects. Okay, called is a functional side effects. Functional side effect is when the functions change either one of its parameter or a global variable. So whereas we change this I is actually I will become a global variable or something like a parameters here, because you put in the pointer k. So this one will change. This I actually will become 14. Okay, so here but here is this one we already get that sum 1 total is 46. So sum 2 total is 48. So why how it become 48? Okay, explain a bit. So here is, I already put something like here explanations. So the first evaluate is functions before this j divide 2. Okay, so functions, it means that I already evaluate this. I will pass this j is 10 to here. Okay, I pass this 10, then 10 is here. It will become this, it will become j, this one will become j equal to become 14. Okay, so k also 14, because this k will become j because we are passing the pointer to here. So here also same, 3 times 41, 3 times 14 will become 42 minus 1. So we still get the 41. Okay, so this one is still okay, same. Okay, here is 41, right? Here also we get the 41. So it's just the same. Okay, the only side effects happen is on the next operand, which is the j. Okay, because this j we put it into the parameters, and we do that, and we have a side effects, functional side effects, because we do some changes inside here in this function. Because in the j, in this function, we make this parameter as a pointer. So it become 14. So this one will become 14. This j will become 14. So it will become 14 divided 2 will become 7. So the sum is 48. So that's why we become 48. So I think I already clear enough. So the main reason why it become difference, the sum even they have the same value, is because of functional side effects in the given expressions, and how because it will make some difference based on how who evaluated first. So here is the first evaluated is his one and second is this one. So here the first evaluate in the sum total, the first evaluated is a function before the this j divide to expression. So we go to the other programming language. So I have here is a C sharp. So this is a C sharp I run is a C sharp, or actually is also derived it to the given program. So here I also have 46 and 48. So it's just similar with C++. Here I only need I don't use the pointer. Here I use a global variable. Okay, so global variable is here. I make this k in I j as a global variable. I create a main method. I create a static functions and a function 1 and function 2. So there's a function 1 and function 2. Okay. So it's just the same when I call this I here in the sum 1 is I divide 2. I make this I become 10 divide 2 equals to 5. Then I call, because the first evaluated is here and the second operand evaluated is the function. So this function I passing the value of I, which is I passing here in the I is a k in the 10. I passing the here the parameters to 10, which is I call out the I global, my global variable, static keys and my global variable become 14. Actually 10 plus 4 equals to 14. So 3 times 14 equals to 41. 42 minus 1 equals to 41. So it will give you the 41 here. 41 here. So here is will become 41. Here it become 5. So 5 plus 41, we get the value of 46, which is correct. In the second expression, sum 2, is the first evaluated is a function before this j divide 2. So function 2, sum 2 is also I create a separate functions, which is I pass the value of j, I pass a parameter j, which is 10, to these functions. So here I call the global variable j, which is currently is 10. I add 4, so it becomes 14. So 3 times 14 minus 1 is also 42. 42 minus 1 is equals to 41. So here I also get the value of 41. When I do the summation or addition, j now will become 14 because this one is a global variable. So it becomes 14 divided 2. Okay, so it was 7. So 41 plus 7 equals to 48. So that's why this sum 2 is equals to 48 and sum 1 equals to 46. So this also a reason of functional side effects on the given expression, because functional side effects will be it may be it will something it will the calculation will be different based on who evaluated first. Okay, so that's the main reason. So main reason of this why it 46 and 48 with the same given value. Okay, another one is in code is in the Java. Java is also same thing, same what I did in the C sharp. Maybe some codings is just only display, just display. So if you can see here, I also have a value of return value or output is 46 and 48. Okay, because it's just the same. In the Java, I also create a global variable and I create a function, separate function. I pass the variable and I just print out. So it's just the same thing. So C, C++, C sharp, and C++, C sharp, and Java are all the same. They have the same output. 46, sum 1 is 46 and sum 2 is 48. So the the main objectives here is we know there's a some side effects on functional side effects on expression. So I think that's all for these laboratory exercises, and I hope I already clear enough. And thank you very much. Bye bye.